Hello, my dear students. Today we are going to discuss about atomic structure. Atomic theory has evolved since ancient times. Scientists have taken the hypothesis of Greek scholars and have built on it with their different discoveries and theories regarding the atom. We know the word atom derived from the Greek word atomos, meaning indivisible. Leucippus and Democritus were the first to propose all matter is made of tiny units called atoms. The two philosophers held these were solid particles without internal structure and came in a variety of shapes and sizes. The qualities such as taste and color, according to this theory, were made of atoms. However, Aristotle strongly opposed this idea. In 1808, John Dalton proposed that matter is made of atoms, which are small, indivisible particles. He proposed that all atoms of one element are identical. They are totally different from those that make up other elements. Then another atomic theory is that J.J. Thomson's theory. In 1904, J.J. Thomson proposed the plum pudding model of the atom. His model postulated that atoms consist of a big positively charged sphere studded with negatively charged electrons, like fruit in a plum pudding. He also proposed that the charge of the positive sphere is equal to the negative charge of the electrons. Another important atomic theory is the Rutherford's model of an atom. Today, we will discuss about Rutherford's model of an atom. We know about Rutherford's alpha scattering experiment. Rutherford passed beams of alpha particles through a thin gold foil to observe the atom and noted how the alpha particles scattered from the foil. Do you remember the observations of Rutherford's alpha ray scattering experiment? Firstly, most of the alpha particles passed straight through the gold foil without any deviation. Second one, some of the alpha particles were deflected by the foil by some angles. Thirdly, 1 out of every 12,000 alpha particles appeared to rebound. Then what are the conclusions of Rutherford's scattering experiment? Most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were deflected by very large angles, indicating that all the positive charge and mass of the gold atoms were concentrated in a very small volume within the atom. Using the observations from the alpha ray experiments, Rutherford proposed the atom model. According to the Rutherford atomic model, the positively charged particles and most of the mass of an atom was concentrated in an extremely small volume. He called this region of the atom as a nucleus. Rutherford model proposed that the negatively charged electrons surround the nucleus of an atom. He claimed that the electrons surrounding the nucleus revolve around it with very high speed in circular paths. He named these circular paths as orbits. Electrons being negatively charged and nucleus being a densely concentrated mass of positively charged particles are held together by a strong electrostatic force of attraction. This is the schematic diagram of Rutherford's model of an atom. Here, a positively charged nucleus is situated at the center and the electrons are occupied in the circular orbits. Then what are the limitations of Rutherford atomic model? Rutherford proposed that the electrons revolve around the nucleus in fixed path called orbit. But according to Maxwell, accelerated charged particles emit electromagnetic radiation, and hence an electron revolving around the nucleus should emit electromagnetic radiation. This radiation would carry energy from the motion of the electron, which would come at the cost of shrinking of orbits. Ultimately, the electrons would collapse in the nucleus. Calculations have shown that, as per the Rutherford model, an electron would collapse in the nucleus in less than 10 to 8 seconds. So, Rutherford model was not in accordance with Maxwell's theory and could not explain the stability of an atom. He did not say anything about the arrangement of electrons in an atom, which made his theory incomplete. The model could not explain the line spectra of elements. Today we have discussed about Rutherford's atomic model. In the next class, we will discuss about Bohr atom model. Thank you.